light. And you know that light is a kind of energy which enables us to see the things around us, or we can see colorful world due to this light. Light falls on different objects and these objects then become visible to us. Even right now, you are seeing this lecture happening in front of you because there is light right now falling on me, captured by this camera and then brought to you. So light plays an extremely vital role in our life. You know that if you miss your keys in a very dark room, you go there but you know you can't see where is that key fallen, where should we look for. Then you take a torch, flash the torch around every corner and that light reflects back from the key to your eyes and you can notice the place of the key. So, to make anything visible, that object should reflect the light. You never flash a torch in your eyes and look for keys around you. You always have to flash torch onto the objects and reflected rays, they come to your eyes. Say you are in the dark, object is in bright light, you can see it. So, the first thing you notice is when light falls on any object, it reflects, it bounces off. But not always that reflection is regular. It is most of the times as a scattered reflection or irregular reflection or a diffused reflection. So you can understand there are two types of reflection. One is regular, other one is irregular or diffused. When I use a mirror in front of me, mirror is a polished surface, smooth surface which does not have any wavy nature. So you can see reflection of objects clearly into the mirror because the rays which are falling onto the mirror are bouncing off like a ball falling onto the wall or hitting onto the wall and bouncing off. You know, when you throw a ball straight, it jumps off straight. So there is direct ball hitting the wall, bouncing in the same way. But if you throw a ball in this way, it will go in this direction. So this is the throw, this is the reflection or bouncing. Same thing works even for reflection, particularly regular reflection. You send a ray in one direction that falls onto the surface, that is mirror or any shiny surface, smooth surface. Then it bounces. If I assume this is a mirror, ray is coming this way, or if I look here, if ray is coming this way, hitting this shiny surface of mirror, it reflects. If I imagine this is a point where the reflection is happening, and if I draw a perpendicular to this is called as normal. So this incident ray, the ray that falls on mirror is called incident ray, bounces here and reflects. So it's an incident ray, it is a reflected ray. And the angle made by this incident ray to the normal is same as the angle made by reflected ray to this normal. So angle I is equal to angle R. I is for incidence, R is for reflection. This is the first law of reflection. There is one more simple law. See, if the ray is coming this side, this is the plane of ray coming, then normal is also in the same plane and reflected ray is also in the same plane. That means ray coming this way cannot come this way out. It will come in the same plane. This is one plane. So, all the three are in same plane. That is the second law of reflection. Now, when light falls on any other object, take an example, I take a book. This is some book. I can see this object. That means light is reflecting from this surface as well. But this is not regular reflection. It is diffuse reflection or scattering of light. Rays falling here are going in different directions. So they are getting scattered. This is called as diffused or irregular reflection. We can see the object because of this irregular reflection, but this cannot reflect off the way mirror will. So I cannot see my face into this. I can see the object, but that is not a regular reflecting surface. It is scattering surface or diffuse reflection surface. So light, when hits any object, light bounces off. Now sometimes light does not come out of that object, it goes through it. Now there are then two possibilities. If the object is clear, transparent like a glass or water, light will enter from one side, come out from the other side. So this entering and exiting of light, that is called as a refraction of light. What does that mean? From this air, light travels in some other medium like glass. Then it of course bends. That bending is called as refraction, and then once again comes out into air. So air, glass, air. Light bends two times while entering and while exiting. So this is a refraction of light. That means if light does not bounce, it may refract through transparent medium. And if some object absorbs that light, does not bounce or does not transmit, then it is absorption of light. Sometimes when it is little dark, you cannot see dark objects, particularly black objects. Yes, you can see some greyish, whitish, colorful objects somehow in the dark as well. But if something is very dark, like black, pitch black, then you cannot notice that object because light is absorbed. A small quantity of light is absorbed by that object. So when light falls, it can reflect, it can refract, it can be absorbed. When reflecting, it can be regular reflection or it can be diffused reflection. I think this is something about light. We have also seen what happens when it is reflected. There are two laws. One is this angle of incident ray, angle of reflected ray, and second is plane. All three are in same plane. This is normal, I just told you. So all three are in same plane. That is the second law. Now the question comes, if we are using more than one mirrors. Some of you might have gone to salons or beauty parlors or changing rooms in some malls, shops. There are multiple mirrors placed around you and you see your multiple images in different angles. So, that is the way when there are more than one mirrors reflecting one object. There are image in this mirror becomes object for this and it once again bounces. So, that bouncing of images gives you multiple images. But prior to that, being I have used the term image, let us know whatever we see inside mirror is its image. That is never real. You cannot get that on screen. You cannot capture it on any surface. It is just visible to your eye. The image appears at a distance behind the mirror. If you are standing here, mirror is held in front of you like this, then you see your face at some distance from the mirror or behind the mirror at some distance. At what distance does the image appear? It appears at same distance or equal distance to the object in front of mirror. If I am standing 30 centimeters away from mirror, my image will also appear at 30 centimeters away from mirror on the back side of it. How does that happen? Take a look. A simple drawing. This is a mirror. A shiny surface is on this side. This hash is normally used for coated, that is backside of mirror. Here is a dot. See, dot, being it's a diffuse kind of reflection from here, it will create thousands of rays hitting this surface. I am just choosing two rays, any two rays. This ray is hitting here. You know I have drawn very small normal and it is reflected here. Another ray hitting here, reflected here. You are seeing from this side. Your eye is here. So what will happen? You will imagine that these two rays are as if joining somewhere behind this mirror, where this dot will become visible. Several rays join at this place, making its image here, and you will find this distance and this distance are just same. So that's the way image is formed behind a mirror. So you have understood mirror. Now go to the mirrors if we are using more than two, or more than one. Typically two. So you may place them making some angle. I have called it theta, or you can call it n. Any name you can give it. How many images will I get when I place some object between two such mirrors which are making some angle with each other? They are making some angle with each other. So what is the possibility? See, right now I am making say tentative angle of 90 degrees between them by two palms. So total number of degrees, if I make a circle of it, would be 360. You know that. 90. So this is 90. So what should you do is divide 360 by 90. I am taking actual angle here. So you know that 360 divided by 90 will be 4, 9, 18, 27, 36. That is 4. Division is 4. Minus 1, that is 3, will be number of images when two mirrors are making 90 degree angle. If two mirrors are making say 60 degree angle, 60 degree, I reduce it. What will be the number of images? 360 by 60, that division is 6. 6 is 36. So 6 is the answer, and minus 1 will make it 5. So when angle is 60 degree, you will get 5 images. If angle is 120 degrees, wider angle than 90, 120 degrees, so answer is 3, minus 1 is 2. So you will get 2 images if you spread the mirror open and make angle 120 degrees. So 120 degrees, 2 images, 93 images, 60 degrees, 5 images, 30 degrees, again 30, 360 by 30, 12, minus 1, that is number of images will be 11. So as you reduce the angle, the number is growing. 2, 120 degrees, 3, 5, 11 and so on. So if you reduce the angle, number of images keep increasing. If the angle between them is 0 and you spread them apart, if two mirrors are spread apart, then 360 divided by 0. Anything divided by 0 is infinite. So that is you get infinite number of images. If the two mirrors are parallel, angle between them is 0 and you get the uncountable number of images. Minus 1 does not make any difference for infinity. So you get infinite number of images if the angle is 0 between two mirrors. So perhaps you might have seen in sitting in salons, if there are two mirrors, front and back mirrors, you can see chain of your face into the mirrors going into infinity. So that's the way you get number of images when there are two mirrors changing their angles. This time we will try to see image formation using two mirrors together. We have two identical mirrors. I am placing them on each other like this, taking sellotape and making it like a hinge structure of these two mirrors. I am placing 2-3 sellotape pieces. and now this can easily open and we can give different angle between these two mirrors. To check that angle, we have this paper protractor. I am placing it this way and let us start. So initially I'll try to take 90-degree angle. So here it is 90, so I can start from this 50 and go up to say 140. So I'm starting from 50 and going up to 140. So this will give you 90-degree angle. So you can easily count 90 degrees and make it. We'll place some object in between these mirrors. See if I am placing alphabet R. And then let us see how many images we are getting. You will find you get 3 images. One is in the center and 2 in these 2 mirrors. So 90 degree will give you 3 images. If I make it say 60 degrees, so I am taking 30 on both the sides, 60 degrees. And if I place this, you can place any other object also. You can easily count. This gives you 5 images. Or if I make 120 degrees, yeah, I'm starting from 30 going up to 150. Once again placing same R in between, you can easily see it gives only 2 images. So as you keep changing the angle, you will find you can get different number of images. Like 2 for 120 degrees, 3 for 90 degrees, 5 for just 60 degrees and so on. So that is the way you can get number of images by changing angle. So now we will do one very interesting project, that infinite street light. I am taking the same 2 mirrors. Remove the sellotape from these 2 mirrors. There is a cardboard pre-punched box. So first thing what you will do is you will fold these on these crease lines properly. So this becomes, once done, it becomes a box of this kind. So make sure that it becomes a rectangular box. We apply sellotape on this joint, but this should be applied from inside out. So this will make box more stable if you apply sellotape inside out. So I am using this sellotape, but prior to this there are a couple of steps. I'll do them first. You'll find there is a double-sided adhesive tape placed here, and on one surface, which is after skipping one, there is another surface which will come exactly in face of this, in the front of this. I have to paste this road. See if it is little bigger, then cut it, because you want that to be of exact size. And now this will fit here. So let us apply sellotape to this first. This is a road print where you can see there are some vehicles as if they are moving. So we have applied this sellotape. Now one more thing further, there is an LED given, white color LED, So you know LED has two terminals, one is longer than the other, longer one is positive, shorter one is negative. Just spread them a little bit. Spread these two terminals a little bit and insert these two terminals through, these two terminals should come up. So insert them here. So their ends come up this way. Two terminals come up this way. So you can make out this is positive, this is negative. And the bulb has gone into the box. Then finally you have to make this box ready. I am taking sellotape. Apply it from inside out. I am applying from inside and then bringing it outside. Do it from other side also. You may apply some more sellotape because this joint must be very good. But always apply it from inside outside so that this joint becomes really good. Okay, I have applied sellotape, so now I can make this box stand like this. It's a rectangular box. You'll find there are two mirrors which are to be placed on two sides like this. So mirror shiny surface will go inside. However, we want one small window in the middle of one of the two mirrors. A small round or square shaped window exactly in the middle. What I am doing is using this sharp point of one mirror. I am just scratching this area off. So this you may do for some time so that this becomes absolutely clean. There should not be any coating remain on this area. It should be absolutely clean. You will find that if you see through this, you should be able to see something in front of you very clear. It should not be hazy. So take some efforts and make sure that this coating is totally removed. Okay, so I have created this small window into this, so you can see through this, right? Now place both of them on two surfaces. While applying sellotape, make sure that sellotape does not come on top of this. So you have to apply sellotape from sides. From all sides you have to apply. You can use any method. You can have even cross sellotape like this. That's also fine. You have to ensure that there are no gaps and you cover it completely. So light should not pass from gaps. If they remain, you should seal them properly. Same, see, make sure that you are not covering this. On the other side, place other mirror. Again, its shiny surface goes inside like this and you apply sellotape. So you are applying sellotape in a way that no gaps remain. So you have done enough now. I think this should be adequate. So this is placed. Two mirrors facing inside. So the box looks like this. Avoid gaps. Okay, now coming to its electrical part. Cell holder has two wires. Remove its insulation. It is already cut, so you can easily remove. Then roll these multiple strands in your fingers this way, so they become a single thread. Normally these wires are multi-strand wires. You must roll them in this way, like this, and they become these all strands come together making a single wire. Now you know red wire represents usually positive. I'll just remove everything from here now. So once again look, this is long, so it is positive, and this is short, it's negative. Now just take this wire, put your thumb on one end of it and just wind it around it like this. And furthermore, bend this in half. So this joint becomes a good and lasting joint. Same way, without allowing this wire to touch other terminal, hold it in your finger using your thumb like this and just roll it around this negative terminal like this. Just keep rolling it and bend it. So both the joints are perfect. They are not touching each other as well. No wire should touch each other. Now last part is using cells. These AA type cells are not given in the kit. So you'll have to get them from home. You know, negative of any cell should touch this spring. That is the negative of your cell holder, like this. And the other cell, again, negative should touch this spring. So I'm placing it like this. And you know, the infinite street light is already there. There may not be a vision for you from here, but look into this small hole and you will see there are number of LEDs glowing as if on top of the street they are illuminating the street. So this is what you have to do, achieve infinite images using two parallel mirrors.